Hello everyone. So the topic that we're going to study today is reactions of acids and bases, which is from the chapter Acids and Bases, class 10th, right? So today we are going to look at the reactions and the type of reactions. Okay. So first is reaction with metals, right? Okay. So any metal, for example, if you're taking any metal, that is, for example, let's say zinc, and we put a metal into acid, any acid. So we have zinc, and if we put it into any acid, so hydrogen gas is liberated, right? We get salt and hydrogen gas is liberated. So this happens when both acids and base, they react with, certain active metals, they produce salt and they liberate hydrogen gas. So I think this practical, you must have done it in your school as well, that, we take zinc granules and we add it into concentrated HCl or dilute HCl. So you see small bubbles coming out of the test tube, and you can see small bubbles in the test tube. It is, very clearly visible. So this is the reaction with metals, right, of acids, that whenever you put any metal into an acid or any base into, any acid plus metal or base plus metal, hydrogen gas is released, right? So let us see. I have zinc and I add sulfuric acid. So we get zinc sulfate and hydrogen. Okay. So now there is a specific test for the hydrogen gas, and that is called the pop sound test. So how do we do the pop sound test? I'll just explain it to you. For example, if we have a small test tube and I fill it with dilute HCl, right? And I add zinc granules to it. You add zinc granules to it, then just put your finger on the top, right? So that, little amount of hydrogen gas, it is collected in the test tube. So put it for around 4 to 5 minutes. And after 4 to 5 minutes, you take a matchstick, a burning matchstick, and you release your finger and bring the matchstick near the mouth of the test tube, and you will see like a very prominent pop sound, right? So that pop sound confirms the presence of hydrogen gas, that hydrogen gas is released. So this is also asked in the exam, that how do you confirm the presence of hydrogen gas? So this is how we confirm the presence of hydrogen gas. So basically, any confirmation or any test, it is, how do we know that hydrogen gas is present? By something that is observable, right? So you can observe something, you can either hear the sound, see the color change, right? Those tests are called confirmatory tests. Okay. So, in our daily life, so, it is not advised for us to store, like pickles, like lemon pickles or citrus fruits in metal containers, right? Because, this acid, it reacts with metals and it produces salt. For example, like here zinc sulfate is produced, so it produces harmful salt. That is why, your pickles and all, generally you must have seen, we store it in glass jars. We don't store pickles in, steel containers, right? Okay. Okay, so that is the reaction with metal. Now, reaction with metal carbonates and hydrogen carbonates. Let us see. So, when acid reacts with metal carbonate, right, or hydrogen carbonate, it forms salt, water, and carbon dioxide gas. So, this we need to remember. Like, for example, I have HCl and it reacts with sodium carbonate. So what do I get? I get a salt of NaCl, right? I get water molecule, that is H2O, and carbon dioxide gas is also released. So you can very clearly see carbon dioxide coming through the test tube, through the mouth of the test tube. Okay. So, and another reaction is, for example, we have acid, and in the acid you put sodium hydrogen carbonate, that is nothing but baking soda, right? So it also produces carbon dioxide bubbles. Now, what are the uses of this, in daily life? So, we make cakes, right? So you make cake or dhokla, and that you add baking soda. Baking soda is nothing but sodium hydrogen carbonate. Okay, so when that baking soda, it mixes with acid ingredient, like lemon or lemon juice or like yogurt in the cake. So again, it acid and a base reaction occurs, right? So it produces carbon dioxide bubbles, which make our cake to rise, and also it becomes very fluffy and tasty. Right, so in dhokla also you must have observed that we put curd, right, and you put sodium hydrogen carbonate, that is the baking soda. So that makes the dhokla rise and it is quite fluffy, right? So in making of breads also this is used, right? Baking soda is used in making of breads and cakes, right? Okay. So again, if you would write the equation, it would be like this: sodium hydrogen carbonate, right? So again, you would get the same product, that is NaCl plus H2O plus carbon dioxide, and you can balance this equation now, right? Okay. So how do we know that carbon dioxide gas is released? Like for hydrogen gas, the confirmatory test was the pop sound test. Here, when the carbon dioxide gas is passed, we collect it and we pass it through a test tube, right, containing lime water, right? So the test tube containing lime water, it turns milky, right? So that is the test for the presence of carbon dioxide. Okay. Now let us see reaction of metal oxides with acid. So for example, I have a metal oxide like carbon dioxide, sorry, copper oxide, and I put it into HCl. So what I get? I get a salt and water, right? This is similar to neutralization reaction. Why? Because metallic oxides are there, and metallic oxides are basic in nature. Metallic oxides, all metallic oxides are basic in nature, like sodium oxide, magnesium oxide, they are basic in nature. So base and acid, if you mix, what are you going to get? You're going to get salt, and water, right? So simple. Any metal oxide reacted with an acid, you get salt and water, because metallic oxides are like bases, right? So you know that base and acid, if we mix together, it is a neutralization reaction and we get salt and water, right? So you can see here, copper oxide plus hydrochloric acid, we get copper chloride and H2O. So copper chloride is green in color, right? So you must have seen that, copper tarnished vessels are there, and there is a dull layer of copper, right? So that is copper oxide. And when we rub it with a lemon, what is happening? The acid reacts with the oxide layer, forming a salt that can be easily washed away. Okay. So the last step of reaction is reaction of non-metallic oxides with basic. So what is the meaning of non-metallic oxides? So non-metals are present in the right side of the periodic table. For example, carbon dioxide, right? Carbon is a non-metal. So this is a non-metallic oxide. Non-metallic oxide, if I reacted with any base like calcium hydroxide, right? So basically non-metallic oxides, they are acidic in nature, and we have a base. So again, we are going to get an acid-base reaction. We are going to get a salt and water. So salt here is calcium carbonate, and we get water, right? So when bases react with non-metallic oxides are acidic in nature. So acid and base produce salt and water. So we have base and non-metallic oxide giving us salt and water. So when carbon dioxide, again, it is added to calcium hydroxide. Okay, so we discussed about lime water in the previous slide. Lime water is nothing but calcium hydroxide. We get calcium carbonate and water, right? So, this is the example why, cement, it contains calcium hydroxide. So it hardens over a period of time by absorbing carbon dioxide from the atmosphere, right? So you must have observed that initially the cement is quite wet, but over the period of time it becomes solid. Why? Because it absorbs carbon dioxide from the atmosphere, right? So let us quickly revise what are the types of reactions that we did. So starting with the reaction with metals, simple here, what we need to remember that whenever acid and a metal reacts, hydrogen gas is released, right? And a salt is formed. And how can you check that hydrogen gas? By a pop sound test. Next is reaction with metal carbonates or hydrogen carbonate. So whenever an acid reacts with metal carbonate or a hydrogen carbonate, salt, water, and carbon dioxide is released. And how do you check for carbon dioxide? If you pass carbon dioxide, which is released in this experiment, through lime water is nothing but calcium hydroxide, the lime water turns milky. Next is reaction of metallic oxides with acids. So we know that metal oxides are basic in nature, right? And non-metal oxides are acidic in nature. So acid and base, again, neutralization reaction, so salt and water is formed. So reaction of non-metal oxides with bases. What are non-metal oxides? They are acidic in nature, like sulfur dioxide. You must have heard about sulfur dioxide, which is responsible for the acid rain, right? It is a non-metal oxide. So non-metal oxides are acids. Acid and bases, again, they give neutralization reaction, right? Okay. So thank you so much for paying attention, right? And for any more doubts, or if you want to study this chapter in detail, we can connect through my Urban Pro profile, right? Thank you so much. Hope you all understood it.